Hello everyone, welcome to All Chemistry. So I'm continuing the whole series of carbonyl chemistry. So here we have done the reactivity of carbonyl chemistry in the previous video. So you can see the link is given for previous video. So see that if you have not seen that yet. So this is very much important for any kind of name reaction, any kind of reaction. So carbonyl chemistry is everywhere and carbonyl chemistry is very important. Now coming about protection of carbonyl group. Now, after doing the reactivity at carbonyl center, so we will go for, suppose we have two carbonyl group, but we have two same carbonyl group, but we want to reduce any one of the carbonyl group. So we need to protect one of the carbonyl group there. So here, protection of carbonyl group required. Now, protection of carbonyl group is done, can be done by various method. Okay, so there are various method. I will not go to each and every method first of all. First of all, I will go for acetal and ketal formation. For a carbonyl compound, what is the acetal? Many of the students have doubt about which one is acetal and which one is called ketal, which one is hemiacetal, which one is called hemiketal. So I will clear that conception first. Then I will go for protection by thiol. So okay, let's get started. Okay, first of all, let's see what is called acetal and what is called ketal. First thing, we have ketone and we have aldehyde. Okay, we have aldehyde, H and R is another group. This one is aldehyde here. And we have ketone also. We have a ketone. So that aldehyde, if we take that aldehyde, then we will get from aldehyde acetal. And from ketone, we will get for ketal. Okay, so from aldehyde we will get acetal and from ketone we will get ketal. Now the question is how we will get that and what is hemiacetal, what is hemiketal? The the intermediate form for acetal formation is called hemiacetal. Intermediate form of ketal formation is called hemiketal. Okay, so let's see. Okay, first of all go for acetal formation. So acetal formation. Acetal formation. Okay. Now we have first of all we have acetaldehyde. We will add acid here means we are adding alcohol. Alcohol I am taking MEOH, methanol. And as alcohol is there, so alcohol can donate some acid. Alcohol can donate some H plus there, and as H plus is present there, and this will be the normal tendency for a carbonyl group. Whenever there is a carbonyl group and H plus in the medium, so that lone pair of oxygen will capture the H plus and they will form H R double bonded O H. So as that O double bonded O have taken one H plus, so a positive charge will come upon H plus upon oxygen. Now you can see there if we are talking about that reactivity of the carbonyl carbon center. So as you can see here, in case of reactivity, there here is a C carbon and here is OH positive. As OH positive is there, so it can pull the bonding electron pair towards itself. So that carbon center become very much reactive as it can be attacked by the methanol, by the alcohol present in the group. So though the alcohol itself is a poor nucleophile, but still as this carbonyl group is very much reactive, so it can easily now attack to the carbonyl center. and it will open up the double bond, then OH positive. Now they will form H, there is a R, there will be a OMe and a OH. Now here you can see here is a OH, a OMe is present. So this is basically called as hemiacetal. So this is not acetal yet. So this one is hemiacetal, one OH and one OMe. Okay. Now in the next step, after that, what we will do? We will do in the next step, we will take that hemiacetal plus is present in the medium. So they will form that H plus can be taken up by the OMe or by the OH. So it will be taken up by the OH because H2O positive will form and H2O is a very good leaving group. Now in the medium MEOH is present. Now that MEOH by its lone pair will attack to that center and that OH2 positive will leave as water. Now we will get H, R, OMe and OMe and water leaves here. Okay. Now you can see this one can be called acetal. So after adding MEOH methanol in presence of H plus or after adding alcohol, so they will form OMe and OH. This will be called hemiacetal. Then after adding second mole of MEOH, okay, so this is a form hemiacetal. Then after adding MEOH H plus another mole, we will get acetal. Means H, R, two OMe are attached to that center. So this will be called acetal. Okay. In the same way we get hemiketal and ketal. So let's go for it. Hemiketal and ketal. So here we have ketone. We will add first of all a methanol or alcohol in presence of H plus. So double bonded O, H positive. Now alcohol can easily attack to the carbonyl center. So alcohol will attack easily to the carbonyl center. Attack to the carbonyl center. Now this bond will be open up and we will get R, R, OH and OMe. And again comparing with the before one, we can call this hemiketal. Then we will add another mole of alcohol in presence of H plus. So after adding another mole of alcohol, this OH will leave the medium as water and we will get here R, R, OMe, OMe. So this will be called ketal. Okay. So this one is hemiacetal ketal. Now the question is how we will use this as a protecting group. So before going to that, I would explain another thing to you. The thing is, look, we have that thing, okay. We have this. What we have? We have this and another we have this. Both are alcohol. Both are alcohol. This one is diol, two OH are there, and this one is monoalcohol. Now, we can react both of the alcohol with ketone or aldehyde. Suppose I have taken ketone here. So I have for first case, if we want ketal, then 1 mole of this diol is enough. 1 mole of this diol is enough. But for second case, if we want ketal, so we need 2 mole of this alcohol. We need 2 mole of this alcohol. And another thing, for first case, what we can do after forming ketal, this will give you a cyclic ketal. This will give you a cyclic ketal. But if we react these two, then we will not get a cyclic ketal. We will get acyclic ketal. Let's go for it in detail. Suppose we have OH, this one diol, and along with we have a ketone, cyclic ketal. Okay. Now here 1 mole of alcohol is enough to form a cyclic ketal. But if we use methanol, so we need 2 mole of CH3OH to get a cyclic ketal like R, OMe and OMe. Two things are here. Cyclic ketal are more stable than acyclic one, and we need here 2 mole, but we need here only 1 mole. So the thing is, ketals are more stable than acyclic ketals or acetal. This is applicable for acetal also. So we will take the diol to protect ketone. We will take diol to protect ketone. And another thing what we can use as protecting agent, that is thiol. Thiol is similar to diol, but just here we have taken SH instead of OH. So we need R, S, this, and to deprotect the thing we need HgCl2, But if we have this one with oxygen, so in presence of H plus, deprotection will happen. So in presence of H plus, deprotection will happen. So for whenever we have more functional groups, so that will not be suitable for protecting agent. Now let's see how we will use that protection deprotection in case of reactions. Suppose we have here two keto group. Okay, we have a compound like R prime. Here is a keto group and here is another keto group. We want this product. We want this product. So what we have to do? We have to protect this ketone. Then we will add Cn minus to this ketone. Now the question is, when we will add this one dithiol, so why this dithiol will protect only this ketone? This can protect only this one when this R prime will be lesser in electron donating than R group. Let's take an example. So let's go for it. Suppose we have a compound like this, O, Me, double bonded O, CH2, double bonded O, Cl. As I have told you, which one is the more reactive one? Here, as chlorine have less electron donating effect. So the more reactive center will be chlorine bearing carbon. The more reactive center will be that chlorine bearing carbon. Now, if we add dithiol in presence of H plus, so protection will happen here. Chlorine is this. Now we can easily add any hydride. We will add any hydride to reduce this center. Now look, if we have added hydride before protecting this carbonyl group, then hydride will attack this group, this fluorine bearing carbonyl group. As we have protected this group, so hydride can attack now this less reactive carbonyl group. So by using protection methodology, we can methodology, we can reduce the less reactive carbonyl group. So for summarization, I want to show you the thing is like Cl double bonded O. And another case, we have taken the same thing. In the first case, we want to reduce the OMe bearing carbon, OMe bearing carbonyl group. So let's go for it. And the second case, we want this. First reaction, so we are reducing the less reactive carbonyl center. So we will protect it first, we will protect this first, then we will add the reducing agent. And the second case, we are reducing the more reactive carbonyl center. So without protecting the group, we will just add here reducing agent. Okay, so this one will get reduced. So this is the procedure how we can use protection agent, protecting agent, and how we can apply this to reactivity of carbonyl group. And thank you for watching. I hope this will be helpful for your basic chemistry, and I will expect from you more like comments what you want, what videos you want, on what topic you want, and please do subscribe to my channel. And again a big thank you to you. Thank you. Please like, share and subscribe to my channel.